From the Library of Congress in Washington, D.C.
So let me briefly introduce our panelists, and then please refer to your printed schedule for more information about all their accomplishments and their experiences. So starting on my far left, we have Jacob Haqq-Misra. Jacob is a, I hope you won't be offended if I say a promising young scientist.
I'm still complimented by young, that's okay.
Yeah, okay, yeah, excellent, excellent. And he recently concluded a postdoc, and he is an expert both in climate modeling of not just Earth, but thinking about exoplanets, other planets. And he also has an interest in ethics, environmental ethics, and he's done a lot of really interesting writing, which you can find online, about some questions of search for extraterrestrial intelligence, on climate evolution, and many other topics. So. Welcome, Jacob. Should I? Yeah, I'm gonna introduce you guys one at a time. So.
So give my piece now.
Pardon me.
My 10-minute little spiel now. Yeah. You want?
Actually, no. Let me. I'm sorry.
Okay.
I'm going to do all the brief introductions,
okay.
And then you guys can just go, so I don't have to interrupt in between. So, yeah, Andrew Revkin is probably known to many of you as the blogger for the New York Times .Earth blog. And he has many other accomplishments and positions, but I sort of think of him almost as the curator of the Anthropocene. His almost daily blog and numerous tweets are a wonderful way to keep track of all the different science and all the different opinion that is emerging and flourishing over all these interesting questions of how the Earth is changing and how we are going to accommodate a planet with a population approaching 10 billion people in the next century. Seth Shostak is the senior astronomer at the SETI Institute, Search for Extraterrestrial Intelligence, and has, in that guise, has a really interesting perspective on the prospects for long-term civilizations in the galaxy, and how that perhaps reflects back on how we think about the prospects for long-term civilization on this planet. Seth is also an author and a radio host. Just look online and you'll find all kinds of really interesting things that he does. And finally, Ken Caldeira is a planetary, what are you? You're a climate modeler. He's a geophysicist who has done a lot of interesting work on both geoengineering as well as changes happening to the Earth now. I heard him give a talk at the AGU, the American Geophysical Union meeting last fall that was, I think, the most interesting talk of the whole meeting, and somewhat alarming. It was about ocean acidification and what might happen to the coral reefs in the next century. It definitely gave me a lot to think about. He's also a musician, but I don't know if that will enter into his presentation today. But anyways, thank you all so much for being here. And with that, let's start. Jacob will now talk for a few minutes, and then we'll just move across the panel.
All right, well, thanks a lot, and thanks for having me. This has been a lot of fun listening to all the other panelists. So I want to start by talking about this question of we. We brought this up, like, will we survive our world-changing technologies? And I kind of want to turn that question around, and let's, suppose that we don't. Suppose that there is an extinction event, and suppose, just for the sake of argument, that this is a relatively instantaneous extinction event. All the humans are gone. So then you ask yourself, well, if all the humans are gone, everyone goes extinct, who is it bad for? Because in order to value something, at least according to, I'm going to get into this a little bit, a consequentialist sort of value framework, we judge the rightness or wrongness or better or worseness of an action based on the consequences for someone, a group, or individual. So all the humans are gone, usually we think about human ethics in terms of a human valuer. Well, the human extinction at best seems value neutral then if you're going to assume a consequentialist framework, because there's just no one else for it to be around. There's no one it's bad for. Now, in conventional economics, we like to think about, we're not really thinking about an extinction event. We're thinking about future generations. We're thinking about making the world good now, but not sacrificing that good for future generations. And so the way that they deal with this in consequentialist economics is talking about something called discounting. And so this is a term where you say, well, I could have $1 now, or $2 tomorrow, or $10 1,000 years from now. Well, you need a way to decide on that. And to some extent, you do want to trade, sometimes you want to trade value now for a greater value in the future, but there's usually some future horizon for that. In most of us, it's our individual lifetimes. Maybe some companies have a larger horizon they can think of, maybe several generations down the road if you're an insurance company or something like that. But by and large, the far future is discounted away. And so whether it's 1 or 2 or 10 or some number of generations down the road, at some point, economists largely stop worrying about that because the trade-off at that far future is just not going to give you the kind of return now that you really need. And so to take that one step further, if we believe what the physicists say now, and we take, where did we come from? Well, there's this big bang that happened 13 billion years ago. We think the universe is expanding, and we think it's accelerating. So to take this discounting argument to its logical conclusion, what happens at the end of time? Well, there's a lot of planets that we could go out and colonize, and maybe, in some science fiction scenario, humans will succeed, and we'll colonize many star systems, colonize a whole galaxy. Maybe we'll reach another galaxy. At some point, it doesn't really matter, because if the universe is expanding and accelerating, which is going to end in a heat death, we may have billions or trillions of years of a robust civilization. But we know it's, unless the physicists are wrong, which, barring that in mind, it seems like we're going to end in a heat death, where all the stars basically fizzle out, everything gets further and further away from everything else, communication will become more difficult. And so no matter how much value we think we can accrue now, whether on planet Earth or in the cosmos, it's going to come to some end. And so I'm not saying that to make the case that extinction is good or extinction is neutral or that we shouldn't try to do this. I think there's a problem with consequentialist ethics. And I think this is showing, it's been brought up in a lot of these environmental arguments that you've seen in the last couple panels. Why do we care about things like preserving an environment? Do we think that a planet has value apart from what it can bring to humans? And I think if we want to resolve these questions, the answer is yes, at least in some regard. The last 10 or 20 years, we've seen this explosion in the discovery of exoplanets, which has reminded us that Earth is one of many potentially habitable planets in our galaxy. That's forced us to reconsider the value of our planet in and of itself. Is a planet a valuable system inherently, or is a planet valuable only in its capacity to provide value instrumentally to humans? And I think a lot of people believe the second thing I said, that the universe and the solar system only has value to the extent that it can be realized by humans. And this has precedent in land use philosophies dating back to John Locke and such. The alternative is to think maybe there is something called intrinsic value, and it does make sense to say that that planet is valuable just because it's a planet. One particular philosophy that's been developed a little bit along these lines is by Woody Sullivan at the University of Washington, astronomer and historian. He calls it planetocentrism. Maybe it makes sense, there's anthropocentrism, thinking about humans first and foremost. Maybe it makes sense to think that planets themselves have some sense of intrinsic value. And the way he describes this is a planet is nature's experiment. And it's not that you might find an icy planet, a dune planet, a planet that's too hot to its star to sustain life, a planet that's too cold. It's not better or worse. They're just nature's experiments, just like a butterfly might have a lot to teach us. So a desert planet has a lot to teach us, regardless of whether or not humans may be able to utilize that for economic gain or for future settlement. And I think adopting that perspective is going to help us adapt to these world-changing technologies, because realizing that there are planets out there and maybe thinking about how those planets might be valuable, it's going to help us reconceptualize the way we value Earth. Because I think right now, the reason we're asking this question, can we survive, is because we're not convinced that this planet has intrinsic value. I think we think of Earth as a very, in many cases, we think of it as an instrumental vessel for what we can gain from it. And we're only now starting to think about the Earth as not just a finite resource, but something intrinsically valuable. And I'll just very briefly add to that the idea of the Gaia hypothesis. And now the Gaia hypothesis, if you're not familiar with it, is the idea that the Earth is a self-regulating organism in some sense. And I'm not going to go very strongly on Gaia and say that the Earth is alive. We can have that conversation later. But what I take away from Gaia is that the Earth is a system. And this point has also been brought up in the last couple of panel discussions. You can go to the moon and enclose a person in plastic, and you create an artificial atmosphere that they can breathe, and you put some hydroponic plants aboard a spaceship. We're basically taking a miniaturized version of our environment and trying to bring it with us. And so I think whether or not space colonization will succeed, it determines to what capacity can we really decouple ourselves from that environment. And I think the answer is that's going to be very difficult because we live in a system. And I think remembering that we live in a system and internalizing that system is going to make it maybe more difficult to achieve space colonization quickly, but I think it's going to make us live longer and last longer on Earth and perhaps have a more sustainable trajectory in the future. So I'll leave it at that for now.
All right. Thanks, Jacob. Andy?
So I'll start with a slightly closer look at the question. Can we form a healthy, stable, long-term relationship with technology in the biosphere? This implies that there is some kind of steady state prospect to look at when we know that all of those three things, us, the biosphere, technology, are all in states of constant flux and are all implicitly unpredictable. We're like one of the least predictable things in the whole matrix. And so what's the answer to that question? The answer is let's dig in on the question. And when I do dig in on the question, I look at us, as I've done for a long time. I first wrote about, I proposed, I didn't know Greek. So back in 1992, when I wrote my first book on global warming, I proposed we were entering a period called the Anthropocene. And it's actually a Wikipedia, I'm like a footnote in Wikipedia now on Anthropocene. But what I said there was that we're basically in a race between our potency and our self-awareness. And I just tweeted this morning. We're in a race between our potency and our self-awareness. And in a situation where the outcomes are unpredictable, even with climate change, we know the basics, but we don't know the most profound things at all. In other words, how warm is it going to get? How fast is it going to get warm? Which species are more vulnerable? What do we know about ocean acidification? It's still kind of in a state of flux when you look at the research. In situations like that, and I grew up for 25 years writing about climate change and these related issues as kind of, in a very mechanistic way, if you reduce greenhouse gases by X tons, you'll end up with Y outcome. And how much biodiversity is enough? I wrote a piece for the Times in 2003 asking that dangerous question, and there's no real answer to that. Of course, it's a value judgment. Which species we save or conserve are value judgments. The butterflies we like, but cockroaches, I don't know. And when you look at all that stuff, what I've done in the last couple of years, I've shifted away from this sense that we even have the right to have an 80 by 2050 climate policy, that we need to reduce greenhouse gases 80% by 2050 because science says so. When you look at the nature of us, you realize that it's just not going to happen. We love energy. I would like to think that there's a price we can set on the dumping of these gases into the atmosphere, but you look around the world and the countries that are doing the brunt of the dumping in the next few decades are still just trying to get out of poverty or at least into middle class living, and who are we to tell them to stop dumping that stuff when we spend 100 years? So the super wickedness there is very super wicked. So what it's led me toward is it's led me away from focusing on like a certain level of parts per million, a certain number of species. And again, in the species environment, you look at the shift in the whole ecological discipline away from the idea that, as you heard earlier, that there's some baseline to get back to, because there is none. So what you want is functional ecosystems. And it is fundamentally anthropocentric, but that's kind of the reality. So stepping back from all that, I say, well, if I were going to, after everything I learned for 30 years as a science writer, everything I learned for 7 years of blogging on this stuff around the clock, it isn't a prescription for a set of outcomes. It's a prescription for a set of traits that you would want to maximize in society. Connectedness is one of them. The ability to move ideas swiftly around the world to where a good idea can mesh with a gap, or where two ideas can meet and cause a fusing that's greater than the other. That's all great. But the idea that that alone will get us there, meaning science alone, technology, innovation, is fantasy too. If you don't have the value set that has some shape for the world you want, you can end up with all this technological innovation and innovation. And I'm a techno-optimist, and that's kind of my bias. Leads you into places you would regret if you were to live long enough. So the traits, and I wrote a piece recently. I did like 7 tweets, and then I consolidated them into .earth post. And this is all just sort of sketching. Bend, stretch, reach, teach, reveal, reflect, rejoice, repeat. And each of those has a meaning. I'm just going to quickly sketch them. I think I'll be within time. Bend, of course, is resilience. You know, the ability to bounce back, the ability, but there's a whole other story there too. Stretch is innovation. You know, the ability to kind of reach for the next thing, to have that capacity, or to reach beyond our planet if need be. So bend, stretch, reach is communication. Reach out to others, empathy. Teach is educating basic science, basic stuff. Reveal is when Greenpeace goes to Indonesia and sees pulp and paper companies and oil palm companies doing things that are fundamentally destructive and immoral, and telling that to the world with creative YouTube videos. That's pretty cool. And transparency is great, so reveal is great. And reveal also includes observing systems, as you heard earlier from, I think it was Dan Biello, talked about the importance of remote sensing, the more we have a sensed planet, the more we have to play with as educated societies. Reflect is to stop and say, how are we doing? Rejoice is to rejoice. You know, religion for too long co-opted rejoicing as like, you know, they're the only ones who can have awe and wonder is to be religious. But I think there's so much wonder, and I don't disparage religion, but there's wonder in science and basic reveling in the state of us and the world. And repeat is the discipline to do it all over again every few years, to kind of assess how you're doing. And I think if we focus on those traits, we'll have a long life. I don't predict, you know, us predicting the quality, stability, nature of life for us 100 years from now is meaningless because it's going to be way beyond our purview, even though some of us will probably live that long, given what's happening with medical technology. But so focus on traits rather than goals, and I think you'll end up with a better world and a long tail on the human species.
Great, wonderful. Thank you, Andy. Seth.
Well, I'm just going to provoke you a little bit by taking the long-term view. I'm surrounded by environmental types here, and I applaud their work. I hope they will improve. I hope you'll improve my future prospects in the South Bay again. But let me look at the big picture here. I'm an astronomer, so astronomers tend to think long-term, as Jacob has already intimated. Talk to you about 4 things that I think are going to happen in this century that I think are special. To begin with regard to the environment, I'd like to just say something cautionary, and that is we're often very wrong because we don't see things coming around the corner. Okay, I mean, if we were having this discussion in London in 1880, people would be pointing out, you know, every winter thousands of people die from the air pollution, and that's because everybody was heating their homes with coal. But meanwhile, at the same time, there's this guy in New Jersey who puts a carbonized thread filament inside an evacuated glass bulb, and that leads to the electrification of all the major urban areas, and that particular problem sort of went away. Yes, I know they generated the electricity with coal somewhere else, but okay, so this was just suddenly a discontinuity and changed things. So, you know, I occasionally consult for movies, thanks to the National Academy of Sciences. And whenever I go down to Hollywood, they always ask the same questions. What will the aliens look like? Why are they here? There's no reason for them to be here, by the way, except the culture. Maybe they like the rock and roll. Who knows? But the other question they invariably ask is, so what sort of weapons will they have? That's interesting to Hollywood. Totally meaningless. If you were to go back 2,000 years and talk to Julius Caesar, say, Julius, what sort of weapons do you think they'll have in the 21st century? And Julius would say, well, they'll have better spears or better shields. Completely wrong, completely wrong. So, you know, long-term prospects are always going to be wrong. But here are 4 things that I think are going to shape the future. We do live in special times. You could have said that at any point in human history. You probably, at the beginning of in 1300, you could have said, you know, we live in special times. I mean, we've got chivalry, and we've got, you know, the Black Plague, and we've got all this, we got this special stuff, okay? But we really do. Here are the four things. To begin with, we're going to understand biology. We're understanding biology. That's the first time that that's happened. Not only, you know, we're sequencing genomes, you know the stories, okay? And you might say that's interesting because we can cure disease and we increase longevity, and all that's true. But we'll also be inevitably tempted to tinker with biology. That's come up a little bit. I mean, imagine you're going to have a kid, right? You go to the doctor and they say, look, you know, your kid could have the musical talents of, I don't know, Nikolai Rimsky-Korsakov, or if you prefer, Elton John, right? That's $50 more. Do you want that or not? Right? Of course you're going to say yes, right? So that's the first thing that's going to happen. Understanding biology is going to change a lot of things, and mostly for the better. So, okay, we can dispense with that. The second thing that's going to happen is that we're going to move into space. Okay? We've heard a lot about space. Stan has said moving into space is not going to inoculate us against self-destruction. I think that's controversial. I think maybe it could. You can say, look, nobody wants to live on the moon under a bubble. And I agree with that. I mean, some people do, but you know, not everybody does. But on the other hand, there are other ideas. When I was an undergrad, and that was just after the Crimean War broke out, my advisor, my freshman advisor, Jerry O'Neill, wrote this book called The High Frontier, in which he said, he said by the 1990s, there'll be tens of millions of us living in rotating aluminum cans in orbit around the Earth. All right? Hasn't happened, because it's still cheaper to build condos in Arizona, but the idea and the technology is all there. And at some point, you'll want to do it, and no cockroaches and no mosquitoes, and you know, you could have a very good life there. Very good life, maybe a better life. In fact, you'll probably feel sorry for those people down on the Earth. Okay, so we're going to do that. Whether it inoculates us or not, I don't know. I think it could. But that's got to happen because there's something else happening. We're running out of a lot of raw materials, okay? And things you don't even think about, like copper and zinc, the easily mineable stuff is going away very quickly. Within 50 years, that becomes a problem. Then you have to worry about burglars getting into your house, not to take the flat panel TV screen, not the laptop, but to take the copper pipes out of the walls, okay? So how are you going to stop that? Well, one thing you can do to stop that is mine the asteroids. And I was talking 2 days ago to a guy by the name of John Lewis. He's a chemist. And he's in one of these companies that's planning to mine the asteroids. You're probably not into that yet. And I asked him, what's the point, mining the asteroids? And he said, the point is, you work it out. The amount of material in the asteroids that we could easily get to is enough to sustain 70 billion people on Earth until the sun goes red giant, and that's the end of the story. So that's a very important datum, okay? So going out into space, I think that's a good thing to do, and we will start to do that. The third thing is I think we'll find life in space. This is my own hobby horse. But I do think that within the next 20 years, we're going to find some biology elsewhere. There's kind of a three-way horse race to do that. One is to find it on Mars, one on the moons of Jupiter, one on the moons of Saturn. There are 7 other places in our solar system that might have liquids. Okay, so they might have biology. We haven't found anything yet, dead or alive, to quote one of the presidents, but we might find it pretty soon. And I've even bet people that we'll find intelligent life within 24 years. I bet everybody a cup of Starbucks will do that. So I'm buying Starbucks stock.
All 7 billion?
Yeah. In any case, I hope they won't collect. But how will that change things? Well, it'll change things only in a philosophical way, I think, largely. It's possible that we'll understand a message and we'll get all this information. Here's how to get along. Here's the cure for death, whatever. That kind of stuff. That might change your life, but I'm not sure that's going to happen. But just knowing they're out there, I think, is philosophically very important. Okay, people aren't going to panic. The government isn't going to shut it all down, as the conspiracy theorists like to say. They won't do that. We've run that experiment 100 years ago. People were claiming there were canals on Mars. People didn't say, I'm not going to work today. There are canals on Mars. They went to work, right? Okay, so going into space, finding life elsewhere, that calibrates us. It shows how important we are. The fourth thing, and then this will, shut up. The fourth thing, and this has also come up, but I think it's actually the most important thing that's likely to happen in this century, and that is the development of artificial intelligence. Okay, you've heard a lot about the fact that, we're going to do this, or we're not going to do this. The facts are, and this is, barring World War III, by 2020, your laptop will have more compute power than a human brain. That is guaranteed. Okay? Your laptop already has more memory than a human brain. So now you've got the hardware for artificial intelligence. It doesn't mean that it can think, right? But that's a software problem. And it doesn't require understanding the human brain. To understand how birds fly is a really tough problem. Birds are very sophisticated in the way they fly. And we don't have aircraft that can do things that a hummingbird can do, run on this amount of fat and, zip around like that. We don't have that yet, but we can fly. So it's the functionality of thinking that's important here. Can we build a machine that can do that? I was in the Stanford AI lab here, I don't know, a couple of years ago, and there was the guy who's the director of the lab. Of course, he's biased, but I asked him, I said, look, are we going to have a thinking machine by 2050? And his answer was very uncomplicated. He said, yes. That was it. Okay, but the point that hasn't been brought out here, and you might think, and I know Stan doesn't go along with this, but doggone it, if I say, can you build an artificial heart? You say, yeah, you can do that. Artificial kidney? Yeah, we got that. Artificial pancreas? I don't know, but probably. But as soon as I say, what about that organ between your ears? Everybody says, wait, stop, hold it, man. That's sacred. You can't do that. Well, there's nothing different about that. That's just more functionality. The point that hasn't been brought up here, and I think this is extremely important, is that once you have a machine that can think, you ask that to develop the next machine. It's not like Darwin. You're not any smarter than the Romans or the Greeks, right? The hardware is the same. You get a better education, you got a better society, but the basic, the thing that came out of the box is the same, okay? Whereas as soon as you have a machine, it's following what's called Moore's law. It's doubling in capability every 2 or 3 years. And that means as soon as you have one thinking machine, within 20 years, you have one machine that's smarter than all people put together. And what that does to our society, I think, puts everything else in kind of a shadow, because that will be so consequential to our future that I think it's worth giving some thought to.
Wow. Well, we will give some thought to that. But, but first, Ken.
So I'm sympathetic to these technologically optimistic viewpoints that have been expressed before me, but I'm going to answer this question in the negative. Can we form a healthy, stable, long-term relationship with technology in the biosphere? I want to present the position that the answer is no.
Okay. Don't look at me.
Okay.
Is that it? Are you done?
No, I could be done there if time is pressing. But I mean, the way I conceive of humanity is that we evolved as hunter-gatherers, and we evolved in small communities, and so we're very sensitive to people who are, to our own personal needs and maybe our family members and close community that we see every day. And so when we think about, so we're ready to, if a cat is meowing or a baby in distress next to us in our visual field and auditory field, our emotional response system responds to that. Similarly, for at least the people who lived in the higher latitudes, we had to think about storing enough nuts or whatever to get ourselves through the winter. And so we developed some capacity for planning into the future, but much of that planning horizon was a few months at best. And now we find ourselves, so we had evolved well adapted to the world that the hunter-gatherer found themselves in. But now we've developed a world that's dominated by technology, and our psychological structure is no longer adapted to the world that we have created. So now we're faced with problems that are global in scale. But I can tell you that if I tell you that there are people, dying of famine somewhere in Africa, and I have a kitten here with a hurt paw that's meowing, that you're going to respond emotionally more strongly to this kitten than to the deaths thousands of miles away. And I think our psychological structure is not adapted to properly balance the problems that face us. So since we have this technological power, we can transform the world in ever more profound ways, and the ways and typically we start changing the world before we understand the ways in which we're going to change the world. So let's talk about survival first. Do I think that humans, say, on the time scale of millennia, or even say in the time scale of millennia, are existentially challenged with extinction? And I think the answer is no. I think humans are very hard to get rid of. I think we're like a lot like rats and cockroaches. We already live from the equator to the Arctic. That we have, even if you had a nuclear war, now we have canned foods in cabinets. We have, there's some people can survive, I think, almost anything you can throw at modern civilizations. I don't think, at least on the millennial timescale, human civilization is challenged. Maybe on the multi-billion-year timescale of expansion of the universe is a different story. So then the question comes, well, what about civilization? How resilient is modern civilization? And I think the answer is we don't know. That I think one thing we saw was that in 2008, 2009, when there was this subprime mortgage crisis, that you had a few million bad mortgages in the US and Ireland and a few other places, and that propagated through economic systems to a 5% loss in GDP globally. And so there's some sign that at least in the financial markets, there are amplifying factors that result in instabilities in one area becoming, propagating globally. And so the question of, if you start shaking our civilization, will it be resilient and robust, or will it collapse? And my tendency is to think that there's a pretty high degree of resilience, but obviously there's no way of knowing. And so then I think the question isn't really can we survive or can civilization survive, but is can we live well? And I do think that it's within our capacity to do the kinds of things that Andy was talking about, and there's nothing outside of our psychology that prevents us from creating a good future. But I think the fundamental problem is really this prisoner's dilemma, tragedy of the commons type problem, where even if we recognize what it would be good to do collectively as a planetary community, the ability to get people to sacrifice locally in space and time for some broader long-term good, while not impossible, is extremely difficult. And so to develop the kind of perspective where people will put the sort of global long-term well-being of the planet ahead of our personal interests, while not impossible, seems to me extremely unlikely. And so while I hope I'm wrong, and I hope that things can change, and maybe, as humans merge with machines, we can get around to actually engineering better human personalities that are more public-spirited. But until that happens, I think the outlook is dismal. So I would say the answer is no.
Okay. Well, thanks, Ken. Thanks, all of you. Before we give you guys should be getting your questions ready, but let's allow the panelists to respond to each other. Anybody want to jump in?
Sure. If I could make a comment about space colonization and resilience, actually. So a couple people mentioned you, Seth, and a couple people at other panels. Does a space colony help prevent, make us more resilient? And I think the answer, well, I agree with you, Ken. I don't think we're very easy to cause extinction to. I think humans are very resilient as we are now. And I think if we were to establish a permanent colony on the moon and everyone were to go extinct, well, is that much better? How long can you really last? Maybe not very long. But I think there is a case to be made for building archives, both in secluded places on Earth as well as somewhere on the moon. It's an idea the late Bob Shapiro and some others have tossed this around. And this is the idea that in a catastrophe, not an extinction event, but a catastrophic event that severely damages our infrastructure and damages our knowledge base, should we be preparing to save our knowledge and perhaps cultural artifacts in the event of a catastrophe so that we can recover and recover in an efficient manner? I mean, one of the examples is there's just thousands and thousands of journal articles published now that most of you have never seen and never will. Do we need to at least somehow archive this for future generations in the event that we have some sort of civilizational collapse, which does have precedent? I mean, the Roman Empire collapsed, the Greek Empire was rediscovered. So perhaps there is some value in having an off-site, moon base, that's really an archive repository, which would then act. It would increase our resilience in the event of a catastrophe. You could imagine radio communication where the moon base helps direct survivors on Earth to try to get sustainable farming going again and build structures and so on and so forth. So I think there is a legitimate reason for human survival to go into space, at least to increase resilience.
Suggest that, I think we're, I hear your pessimism again, but I suggest that maybe we're going through a bottleneck, right? I mean, 100 years ago, well, not even 100 years ago, let's say 50 years ago, you invent the H-bomb, right? So now suddenly you might be able to get rid of everybody. I think the panel's all agreed it's really hard to get rid of everybody, okay? Okay, so that sounds bad, but at the same time you invent the H-bomb, you invent rockets because you've got to carry the H-bombs around, right? But as soon as you invent rockets, now you have the ability within 100 or 200 or 300 years to get at least a significant number of people off the planet. So there's this kind of bottleneck when technology gets to the point where it could be very, very destructive to the entire species, or maybe more, and then a couple hundred years later when you're spread out and now it's hard to get rid of everybody. You're like ants. I can get rid of the ants in my kitchen with difficulty, but I cannot get rid of all ants, okay, because they're dispersed. So this 200 or 300 year bottleneck, the question is, do we get through it or not?
Well, and those rockets that were invented to launch H-bombs also launched a lot of satellites that stitched the world together in terms of knowledge and imagery that are perhaps also providing a kind of resilience and a way to get through the bottleneck. So.
But in one aspect, I agree with Ken. The dark side of our trajectory right now was laid out for me in an interesting way by an economist at the World Bank named Stefan Hallgate, who studies disaster economics on a regional scale, but you could apply this at the planetary scale, where essentially you do incremental adaptation that looks kind of smart at the time. You're actually building risk toward a much more calamitous outcome in the long run, whether it's sea level rise and floodgates, or in this case, getting ourselves, we think we're getting more robust by doing certain things with biology, whatever, when actually that can lead to more vulnerability to a bigger disaster. And that's an interesting issue. Jeffrey West at Santa Fe Institute, I remember a few years ago I was there, and he had this, he's this physicist who thinks about these big problems, and he had this kind of upward scalloped curve showing how big innovations have led to these nonlinear sort of spikes in our potentiality, and then we just have to speed that up. And when I put that together with what Stefan Hallgate has written, it's kind of like a scary scenario. And that's why, again, I focus on traits because I cannot see a way forward except to think about those kinds of.
Yeah, I mean, by both, probably if we were here at the late 19th century, I probably would have said the same thing, and then we would have had the next century of improving quality of life. And so, I mean, there is this tendency to look to the future and see doom and gloom, at least for me. But then the actual record is that for the average person on this planet, life has been getting better.
By the way, Matt Ridley, who wrote a really provocative and interesting book, The Rational Optimist, a few years ago, the thing that disrupts everything is anti-technological fundamentalism. Whether it's Islamic fundamentalism or the other kinds of anti-technological fundamentalism. So there are ways for that system to break down.
For a while, I worked at Lawrence Livermore National Lab and had a chance to interact with Edward Teller a few times. And he was a technological optimist in that he thought, Star Wars missile defense and H-bombs could solve all our problems. And he was a pessimist about human nature, and he thought, well, if we can get the right technologies and build the right systems, that even people with flawed psychologies can have good outcomes. And I think, I'm not politically sympathetic with him, but I think that basic perspective of that humans have fundamental psychological flaws, but that we are capable of thinking and creating systems. And so how do we design systems that allow us, or all these flawed components to at least function well. But our brains, each neuron is flawed, but somehow the whole thing kind of works.
All right, well, fascinating questions. I think this would be a good time to open it up to the floor. I see a gentleman right here. Where's the, Jason's coming with the mic. We'll go right here in the middle, and then over here in the front row. Yeah.
It's on. You hear me? Okay. In answer to Ken's last point, a man named Rodney King, after being beaten by some California policeman, said, "Can't we all get along together?" Which I think is a hopeful sign. I don't think I'd have been at this kind. But
Learning moment or teaching moment?
Recently, this week, in the New York Review of Books, there was a book by a man named Gershwin reviewed, which said that the thing we have to fear right now is jellyfish taking over the sea, which no one had thought about before. Is this better? Okay. Due to water warming and overfishing, there are fewer fish left. And they're going to do us in, or do in the oceans, which is 2/3 of the surface.
Yeah, I mean, I haven't read either the book or the review yet, but just in general, in biological systems, both on land and in ocean, disruption favors invasive generalists, and so things like coral reefs or rainforests that are tuned, or Arctic ecosystems that are tuned to a very narrow range of circumstances, when they're disrupted, simpler, rapidly reproducing, rapidly spreading species. Yeah, but I don't, nor do we want to kill them necessarily. And I think this is kind of a lot of the future about living versus living well. I mean, wherever there's light and nutrients, something's going to live, and the less we interfere with the planet, the better off the biosphere is going to be.
Just on that point, there's a John Bruno who studies coral reefs in North Carolina somewhere, I think. Anyway, he wrote something, he had a paper a couple of years ago that I wrote about, and it was about, there's basically a battle underway in the coral, this is separate from the jellyfish issue, but between corals and weeds, you have like a weedy ecosystem and a coral ecosystem that are kind of vying for the same substrates. And I asked him, when we had this discussion about his paper, I said, is either one more or less biodiverse? And he said, actually, it's kind of a wash in terms of productivity and stuff, like basic primary productivity. And so that says to me, you know, we love coral reefs because we grew up with the world of coral reefs, but 100 years from now, our great-grandchildren may be growing up with the world of weedy reefs, and they might think, you know, they'll read a book about coral reefs and they'll think, wow, that's kind of weird.
This gets to the whole timescale issue that for my PhD dissertation, I looked at the aftermath of the extinction event that wiped out the dinosaurs. And you know, in one respect, I see humanity as kind of another meteorite smacking into the planet, although we're taking a few centuries instead of an afternoon. But you say, like, it was that meteorite, it wasn't good or evil, it was just this change. And so, you know, if you step back far enough, you say, well, look, we're just another thing that happened on this planet.
We theoretically have a brain. Which
right. But again, emotionally, we're tied to things that are local in space and time, so we care about things.
Well, and one thing I think I learned from Ken's talk at AGU last year was that the reefs have gone away before because of ocean acidification, and then they've returned. And this has actually happened several times, which, you know, in a certain sense is comforting, but it doesn't necessarily get us off the hook.
The time scale of return is, you know, 500,000 years, million years, something like this. And so, again, if you're taking this sort of geologic lifespan of the universe kind of perspective, it's all a blink of an eye. But if you're thinking of going shopping for food or something, it's a long time.
Right. Yeah. Okay, we have a question over here.
Long checkout line if it was 500.
I just wanted to follow up on Ken's comments regarding the cultural and political response to crises that face us on the globe. And to me, it seems important to go back 200 years and remember George Washington's famous comment to the Continental Congress sitting in Philadelphia after the Battle of Long Island. He said, you know, we need a standing army. I'm paraphrasing what he said, but we need a standing army. We can depend on militia so long patriotism will carry them through the first battle, but after that, interest is what will carry the day. They have to have self-interest, they have to have political interest and so on, and other reasons. And so if we apply that to current crises, let's take one example. Let's look at the chlorofluorocarbon crisis of 20 years ago. It wasn't until the nations of the world, the people as well as the political institutions, recognized that there was a threat to all the nations, and they each had an interest in solving this problem, that it was possible to solve it, and it was solved. Same thing today, right, with the carbon crisis. People now see more intense hurricanes, more of them, and greater desertification and so on. So I think for the politicians, for the sociologists, for the atmospheric scientists and other knowledgeable people to bring forth these issues and help to encourage this development of a consensus towards solving them is the way in which humanity can actually prevent them.
Well, yeah, I mean, this is exactly right, that I mean, any individual actor still had the incentive to emit CFCs, and it was creating this policy environment that changed the incentives and the disincentives, and so that without changing psychology, those same people could act in more ethical ways. And so it's really engineering good policy and good systems that's the key.
But there's a big but, and the big but is CFCs were like this much of the economy and had no real cost. Companies had worked hard to they knew what was coming. They saw the early papers and they developed substitutes that were affordable so you could transition to a post-CFC world, as we still are doing in developing countries, without Sturm und Drang. But with carbon, it's a completely different scenario. And I've written about, I used to, you know, there was this whole meme, well, we did it with CFCs, we can do it with carbon. It's just a completely different animal economically.
I'll add to that, CFCs are a lot more easier to communicate the science of. There's a couple, you can write the chemical equations on a chalkboard, and you can show a nice big picture of an ozone hole. Climate change, there is that evidence, but you get people contesting the hockey stick, and it's a little murkier when you're faced with a skeptic, I think.
Well, it's a harder problem, but I do think that it does serve as proof of concept.
Yeah.
No, it's really completely different economically. It's fundamentally different. We're talking about multi-trillion dollars versus sort of tens of billions of.
I had an old car with a leaky air conditioner, and my mechanic offered to get me some bootleg Mexican CFC.
Oh, God. Did you call the police?
I didn't go into that.
Let's see. Oh, back here. Yeah.
I was going to ask Andy, you said it's a completely different problem, the carbon problem from the CFC problem. But I wonder if it really, I mean, it's a much bigger problem and a much longer term problem. But there are people working very hard. There are people working very hard to, okay, it's doing something bad. There are people working very hard to discourage development of new technologies that at least have the potential to solve the problem, and it gives me hope, because it makes me think, well, if they're trying to keep people from moving toward photovoltaic technology or other technologies like that, it must mean that they're actually concerned about it. I mean, I agree that this is a huge problem, but I don't think I think there's a potential to accept that because it's huge, it's insoluble, but I think there are definitely vested interests that would like you to think it's insoluble.
Well, I would like to bounce that to Ken, because we had some long talks about California. So let's take California as like an example of a place that has the can-do attitude and has the legislation, and is going to go to 80% something, reductions by 2050. How realistic is that, Ken?
I haven't done a detailed technical analysis, but I would be surprised if California actually achieves that. I would just like to respond to one statement. I think there's a lot of people trying to develop clean technologies, and the main problem is that they're more expensive than the dirty technologies. And then again, there's public policy that we need, and we need technical innovation, but it needs to happen in a good public policy environment.
A good public policy environment. That's where we're at. Isn't that what we have right now? Talk about catastrophes.
Let's see. In the middle right here. Yeah. Yeah.
Franz again. You were discussing the issue of intelligence generally and possibility of planetary intelligence. one of the goals of, or the biggest goal of astrobiology, I guess, is to see if we find intelligence elsewhere off of this planet. And we seem to associate intelligence with complexity, being able to store information, transmit information, duplication, diversification. So in other words, an intelligent expansion of complexity. But doesn't that seem to be kind of reflective of ourselves? It's just looking in the mirror. It's kind of like our search for intelligence is part of our self-licking ice cream cone syndrome, where we're looking for ourselves. And has anyone considered that possibly we are staring at superior intelligence every time we look in the telescope because of the self-organizing property of big spheres? Does there come a point where intelligence, as it progresses, Hegel might have said the same thing with his whole dialectical progression, but does this complexity come to a realization that it's actually a simplification that we're after? And that this simplification would manifest itself in beautiful symmetries and forms like spheres. I'm just saying, are we prepared to recognize those types of radical concepts of intelligence? And I stay away from the issue of consciousness because I don't think any one of us can verify consciousness in anything else. So that issue of self-consciousness, we can only verify ourselves. But in terms of intelligence, is it possible that we can look at the simplified nature of massive spheres out there as properties relating to higher intelligence? I don't know. I throw that out there.
Let me say that in the SETI field, which is where I work, of course, looking for extraterrestrial intelligence, we have an operational definition of what it means to be intelligent. If you can build a radio transmitter, you're intelligent, and that's it. And everybody in the room should ask the person sitting next to them, hey, can you build a radio transmitter? And you know how to treat them the rest of the afternoon. That's an operational definition. We don't have a good definition of intelligence. We don't have a good definition, as the astrobiologist would tell you, we don't have a good definition of what it means to be alive. I mean, you know, you can say, like Justice Potter said, I'll know it when I see it, right? But he was talking about something simple called pornography. If you talk about life, you can say, okay, I can tell whether the things in the National Zoo are alive. You know, the big megafauna, that's not hard. I can tell whether bacteria are alive, that's not hard. But if you get down to the level of a virus, suddenly it's getting harder. And when you look for life on Mars, you don't know necessarily what to look for. So I think the same is true when it comes to intelligence, that indeed there could be, you know, forms of intelligence that we simply, you know, like the third son, you don't know enough to even ask the question. All right, so that's possible. But to say that, well, looking at the way the universe is built, that might be the result of some super intelligence, you know, or the self-organizing ability of spheres. I mean, Isaac Newton had an explanation for that, an operational one. You know, I don't know that you can get very far with that. That would be like saying, there's a great party going on in this room in the 10th, 11th, and 12th dimensions, which there might be, but since you can't get in there, it really doesn't matter.
I'll maybe add to that. I think it was Frank Drake who said that SETI is really a search for ourselves. And I think your comment is exactly right. We could be staring at a super intelligent being or civilization and not know it, because all we're going to be able to recognize is something that's like ourselves. I want to mention actually an aspect of SETI that I think is very relevant to this question of human extinction and our survivability is if we were to discover an extraterrestrial intelligence, and we'd only be able to discover this because we had something in common, whether it's we both use radio transmitters or lasers or something like that allows us to establish communication. We know we have that in common. We now have an extraterrestrial valuer, and we no longer need to worry about where our value comes from. And it's important philosophically. The philosophers, they can resolve some epistemological questions. But this is a reason a lot of people have been religious, is because people need to find value from without. And you look to some supernatural, deity that exists beyond the realm of nature that then can bestow upon us value and help give us insight to our ethics. Well, as soon as we discover an extraterrestrial intelligent civilization, we might not know very much about them. We might only know that they send radio signals. But even if we know that, we know they exist. They're capable of valuing us. They might hate us, but it's still a value judgment, positive or negative. They're capable of valuing, and they're capable of saying that there are some things that we value in common. And at the very least, it'll help us start to think critically about what we value ourselves. It gives us an experimental, empirical data point for our terrestrial ethics. It might not be very much. It'll depend on how much we learn from them. But I think even if all we find is that they exist and they use radio telescopes, it'll help inform our ethics a little bit.
Well, not only that, but as Seth has pointed out in some of his writings, and other people have as well, we only have a decent chance of detecting extraterrestrial intelligence if there are very long-lived civilizations, because if all civilizations are very short-lived, then there's just not enough communications out there. You can do the math and show that. So therefore, if we detect them, not only is
There's actually
somebody
two
out
things we
there,
might learn. They use radio and they live a long time.
It's an existence proof that it is possible to have a sustainable...
But it almost certainly means that, in fact, somebody has solved the problem of how to do this technology thing for millennia.
That's right. And we're going to ask ourselves the question, how can we be like that? Yeah. We might not do very well at it, but as soon as we make that discovery, we're going to want to try to be like that.
So maybe it's having science fiction folks in the room, but I think there's some hope through this man-machine merger, because normally you think, okay, you'll make a mechanized kidney or something, or maybe put a calculator or some extra memory on your brain, but the idea that we might engineer ourselves some better ethics so that we consider
Ken, you're hung up on this.
We're doing that.
You want to become part of the Borg, I can hear it. But it isn't going to work out that way. Sure, you're going to put chips in you so that you remember everything, and you're a walking Wikipedia, whatever. All that'll happen. But I've said before, I think that this is like putting a 4-cylinder engine in a horse, right? You get a faster horse, but very quickly thereafter you say, can we get rid of the horse part and just build the Lamborghini, right? So, the mind meld, I think it'll last very long.
Okay, so we'll get the robots with better ethics.
But I think technology is, the thing you're talking about is already happening. It's just, it's a little invisible because it's global. And I've written about this a lot, this idea of the noosphere, as they used to spell it the Greek way in the 20th century. I've been spelling it noosphere, like K-N-O. But essentially planetary mind. Tim O'Reilly calls it the global brain. What's happening is we're going to end up in a battle between each of us saying, I'm still a brain, but the global mind is saying, no, you're just a neuron. But what's happening, just keep that in mind. That's going to play out. There'll be epic wars over this in some way. But we're building the capacity for empathy and for awareness that's never been there before in a way that I think will play out. When kids are co-learning, in 2009 I was in a really tough slum in Istanbul, and these little kids were running up to me. I was there to write about earthquake risk, but I ended up writing about other stuff too. These kids are running up to me. None of them owned a computer, and they're saying, Facebook? That was what they were saying. That was their English word, Facebook. And several of them are my Facebook friends now, these little kids. And to me, Google's working on these instant translation algorithms. Empathy is coming through that.
It's really, I know some people do this all the time, but there was only once where I followed a breaking thing, and some Israeli tanks were flattening some Palestinian village, and the Palestinians were tweeting it, and so like real time, oh, the tank's there. And it was this like emotional engagement with this thing on the other side of the world that you never would have absent this technology.
So I think to some extent that can happen, but you have to have intentionality.
That's right, and I think that's the antidote to your point that human nature is flawed in this way that will prevent us from solving these problems. Human nature is not necessarily this non-malleable thing, and in fact, this technology we're discussing is changing human nature. It's changing the way we act in the world and making us more global and more mindful of people and more aware of things in distant places. And that's huge. And we don't know how far and where that's going.
No, it's true. I mean, one of my best friends now is in China, and I've communicated with him a couple of times today already. So it's...
Can I quote from Darwin, 1871, Descent of Man, his less famous book? In 1871, Darwin wrote, as man advances in civilization and small tribes are united into larger communities, the simplest reason would tell us each individual that he ought to extend his social instincts and sympathies to all the members of the same nation. Okay, step one. Though personally unknown to him, this point being once reached, there's only an artificial barrier to prevent his sympathies extending to men of all nations and races. And now, again, the artificial barrier is being surmounted by technology. Now, this can all go in various directions, and that's why I'm not predicting this will make us all happy, big group hug, global group hug, you know, but I think the potential is there with intentionality, with...
We can start with an audience group hug.
Yeah, there we go.
Not only is that a pertinent and hopeful quote, but the fact that Andy and his laptop were together able to deliver that. I submit that without your laptop, you might not have been as good. So we've got an example of machine-human hybrid helping out here. We need to keep the audience involved.
Eyeglasses.
So I think we had another question over here.
You've already got that machine connected to your brain. Right?
I just had a comment. The idea of having a chip that would be implanted or something that would be implanted to give us ethics, we already have this as an upload mechanism. We're great uptakers of information, and we have societal norms. We have the concept of the fable. We have stories, we've been hearing a bit about that today, that teach us how to behave and how to get on well with others. We have religion, so I would suggest that we already have that, and in this case, a hardware solution might not be the way to go.
But we have incompatible ethics among different cultures at times.
Oh, yeah.
And that's the biggest problem in going from morality. Some people will talk about morality, which is oftentimes, you know, a religious thing or prescribed or something like that. And it's very difficult to really keep talking about morality without appealing to some sort of higher power. And that's why we talk about ethics a lot of times, because it's easier to talk about ethics as just a prescribed set of norms that govern how we act in a certain sphere. And so morals, achieving a universal sense of morals has proven to be very difficult because of cultural differences.
So the thing that we need really to be striving for is cooperation rather than having a certain ethic that we need to work towards.
Something that's very close to ethics and norms is the human desire for peer approval, and that, I mean, my sort of hope on the climate problem is that at a certain point, it'll just be socially acceptable to build smokestacks and tailpipes, and people would be embarrassed to even suggest that you dump CO2 into the atmosphere. And so I do think that this development of norms is sort of the most realistic place to place one's hope.
I think there's also ethical issues that seem obvious to us that are more difficult to resolve given our situation now, whereas 2,000 years ago would have been easier. This actually gets back to something, Seth, you were saying about biological advancement. And I'm certainly not going to deny that we've made tremendous leaps in prolonging life and artificial limbs and hearts and things like that. But there's a point that was made by Sebastian von Horner in 1960, which is that, I don't want to offend anyone, but I'll say eyeglasses, you know, is something, David, I hope you're not offended. You know, we've sort of, there are certain things that are no longer selected for. You know, if you wear eyeglasses, you just get a prescription prescription glasses, you can still reproduce, and that trait will probably be carried on to your offspring, who will then just continue getting glasses, and sometimes that may lessen, sometimes it might get worse. So glasses is a very trivial thing. That's something maybe you could imagine technology fixing relatively soon. We have, you know, laser eye surgery and such. But, you know, something maybe a little bit less easy to address with conventional medicine, you know, things like hereditary diseases, you know, autoimmune diseases or something like that, that are hereditary, that don't have a well-understood genetic basis. They do pass between generations, and conventional medicine is treating the symptoms rather than eliminating the disease. And so after several generations of this, you're actually building up a weaker population because you've allowed these hereditary traits to build. And this is a very difficult ethical question because if you, you know, I guess the analogy in nature is you've seen a mother goose with like 6 ducklings, and then the runt is left on the side of the road. You know, I've seen this, and it horrifies us. We say, well, take the runt with you. This is a living thing. And for some reason, you know, geese and other creatures have decided that it's a better evolutionary strategy to let the runt get eaten. If we do that, you know, you get arrested for leaving a small baby to die. Like this is something we've decided is unethical. But at the same time, because we've decided this is unethical, it's going to create biological problems that I don't think are as easy to fix as, you know, just a replacement heart or something. Maybe it's addressable. I think that's going to be something that will create a lot of problems down the road.
Interesting. We had a question in the second row here.
Yeah. First, a couple of comments. In terms of public policy, when New York City banned smoking in bars, I started believing anything is possible. So it could happen. But in terms of resilience, by putting extraterrestrial colonies out there, Back in the 1950s, a lot of people built bomb shelters to try to survive a nuclear attack. And they weren't planning to build a civilization within the bomb shelter. They were planning to stay there long enough until conditions returned conditions on the surface returned to where they could go back. And I think that's where the resilience is going to come from.
I completely agree. Yeah.
Well, there's just one quick response. Within those writing a lot about resilience, there's been some pushback on the whole idea of resilience because it means it always presumes you're bouncing back to the current state. And finding different definitions for the durability that you would require in a changing climate or facing unpredictable biological outcomes is not always to bounce back. It's to find ways to sort of leap forward in different directions. So even the whole concept of resilience is kind of wavery right now. It's interesting.
Although I would say the value in that type of resilience that comes out of a bomb shelter is you're right that the future you enter into might be very different, but you don't want to take 10 steps back. You don't want to lose
for sure.
all, it's worth putting a seed bank, somewhere safe so that you're not starving and, learning how to forage for food.
I was in the Arctic in May in Svalbard, this island in the 82 degrees north in Norway, and I got to see the door to the seed vault, which I didn't get to be there when they inaugurated it, but it's really bizarre to see this door into the side of an Arctic mountain.
I have to say the bomb shelters worked, right? We survived the Cold War.
Yep.
But the kind of colonies I'm talking about, for example, the Jerry O'Neill, Tom Heppenheimer colonies, these rotating aluminum cans in space, they're not there to escape the mosquitoes of Earth, right? They are new habitats. And all I was suggesting is that while you may rail against that because you're used to what you have, it's like moving to New York City. Nobody could ever really live there, right? But in fact, it might be possible. And so keep that in mind.
We are a pretty flexible species, aren't we? We had a question back here.
There was a Singularity Summit in 2012 which took place in Australia, Melbourne. And there was a futuristic prediction that we will we are progressing towards what is called a technological singularity. And that year is 2017, peaking at 2116. So I wanted to know what the panel had to say. And the second question, I'm a biologist and an educator. We are the inventors of technology. So the question here, can we form a healthy, stable, long-term relationship with technology and the biosphere, seems a little, misplaced, the question. So should we ask that question at all?
What question do you put in its place?
Can we form a healthy, stable, long-term relationship with technology and the biosphere? We have no other choice.
That's true.
We started with being Homo erectus.
Well, we do have
talking
a choice.
of human evolution. Then we came to being Homo sapiens. A lot of spiritual people are talking about the Homo luminous, the luminous man. Then we said Homo ludens, the playing man, and Des ludens, the playing god. Now maybe it's just time for evolving into Homo technians.
Let's hope it's not a stable relationship to begin with, right? The ancient Egyptians had a stable civilization, and that's not, curiously, it's not stable, so you don't want stable. But as far as your first question, the 2017 and the singularity, there was a lot of discussion of the singularity earlier today. And Ray Kurzweil, I don't even think, would say that the singularity is going to happen in 2017. But Ray also says he's going to live forever because he figures as he gets older, we're going to be increasing lifespans by more than 1 year per year. And that puts him in the clear to live forever.
Wow.
Now, he might be wrong about that. Okay.
Might be.
Yeah. He might be wrong about that. And the date of the singularity isn't really the point. It's not going to be 2017, that's for sure, when the machines all wake up, right? It's not going to be 2017. The only question is it going to be ever? And the answer to that seems to me yes, but that's my point of view. The fact that it may happen in 50 years or 100 years really doesn't change the long-term outlet. It just changes outlook. It just changes the outlook for you.
So to get to your second half of your question, I think we have to have a long-term relationship with technology in the biosphere, but it doesn't necessarily have to be healthy. And I think this comes to the point of that civilization will persist, but can we make it one where people flourish? And so the challenge is really in the word healthy. And can we establish healthy relationships? And I think it's possible that we I mean, I think technically we can, and I think it's really has to do with, do we have this sort of emotional capacity to do it?
And there are some paradoxes. One, just look at what Jesse Ausubel and David Victor and others have written for years about technology in agriculture is the best way to preserve space for a lot of biodiversity. In other words, if you like forests, you better like industrial style agriculture. Because if you do all agriculture in this sort of dispersed, low intensity way that organic is done, you end up with, for 9 billion people, as we go through this growth spurt, you end up with very little room left for nature. If you do it in a concentrated way and you deal with your wastes, et cetera, then that's better for nature. So the value judgments are in there get really complicated in a hurry. The things we sort of feel like we like, you know, I live in the Hudson Valley, I love eating local produce, but 9 billion people doing that has a hard time fitting in our, on the planet.
I think one interesting thing is that you don't hear anybody on this panel saying, oh, the way we have a healthy long-term relationship is by getting rid of technology. I think we're at a point when you have so many people on the planet that you need technology, and so that if we are to have a healthy long-term relationship with technology in the biosphere, it's through improving the technology.
And one last, I don't want to say too much, but
go ahead.
There's some really interesting guys at IASA and women in Austria, the International Institute for Applied Systems Analysis, who do this long-term population consumption modeling. And you know, some of their scenarios go, and this gets to the point that we're going through a pulse right now that is pretty unique. You know, we talk about chronocentrism. There is a lot of evidence that right now, actually for the human species, and our history is a unique juncture in the sense that some of their outcomes by 2300 have a world of like 2.3 billion people living in. When you have 2.3 billion people on this planet, if we get through this bottleneck, as you've heard in other contexts, my God, you know, you can have like, everyone can have organic agriculture, and we can probably get rid of a lot of technology. And so a lot of what we're talking about, I think, is can we survive the 21st century?
Right.
And finding strategies to get through this. It's kind of like a cresting wave, a wave that's been building and cresting. And then after that, you end up with this long slope toward some different future. The idea that it's going to be 10 or 20 billion is really hard to, 20 billion people is completely feasible. Probable, we don't know, but there are outcomes that are very different to think about.
Let me speak to that just for a second because I came up with that much maligned question. The term healthy, I mean, there are a lot of wiggle words in that phrase. The term healthy speaks to some of what we were talking about with our first panel, and we keep returning to it, I'm sure we will again at the end of the day, which is about values. What do we mean by a healthy relationship? What do we want? What do we care about? What do we want to preserve and perpetuate into the future? And I think the reason I used the word stable was, I mean, as has been pointed out, stable, there's relative degrees of stability. And I don't think anybody is arguing that stasis, which is sort of the ultimate, I mean, that's heat death, that's the end of the universe, right? But I think I use that word because, you know, there is this sense of a bottleneck, and if you look at all of these, you know, the papers about the Anthropocene, they show all these exponentials trending now in, you know, population, in atmospheric variables, in land use, in, you know, perturbations of the hydrological system. There are all these very rapid changes that cannot persist. We cannot persist in the mode of instability, the level of instability that we're at now. And what's interesting about technology, of course, is that it keeps changing, and it will keep changing. It's about innovation. It's not going to be like, well, we finally reached the technology we want, and that's it. We're all just going to keep it the same. So is there a way that we can have a society where that innovation and that change of technology, which will keep happening, keeps on happening, and yet we somehow keep those physical bounds that we need to have whatever we define as healthy, you know, still persist. And so that's, to me, the question of stability within certain bounds enters into it.
Any practice or technology that you know, has a positive impact on the biosphere. Yeah. So that's why I was wondering the healthy and the stable model.
Yeah. Thank you. I think we had a question over here in the front row.
Much of the conversation has been about a futurist exploration of how to deal with the question of extinction. There might be an immediate model to look at the same question in a somewhat historical way, because in 1969, a woman physician in Chicago was invited to study some dying patients in a hospital. She was invited to do that by some pastoral counselors. And she went to her hospital and she asked if there were any dying patients. And the response that she got from her colleague, she was a psychiatrist, was that there were no dying patients. So she went back after a week because she was sort of doubtful about that possibility. And she found out that many were dying. And she went back to her colleagues and she confronted them and she said, I know your patients are dying, could I see them? And what she found among her colleagues was that they were so consumed by solving problems, technologically and scientifically, that they had essentially reduced life to a problem. And when it became clear to them that the patients were dying or extinguishing, she found out that they ignored it and that they were left by themselves and they weren't told that they were dying and the families weren't, and then they would just go quietly into the still night. And what she did was she blew a whistle, and the result was I think she created, in a sense, not only a field about death and dying, but she also created something very different in an epistemological way, and that is that she showed that you could try to solve problems in your patients, but when it becomes clear that you can't, and we're always going to be confronting a can't, then you shift to another mode. And one of the panelists earlier today said, it was you at the end, that we sometimes resort to a higher power when we confront these situations. What she did was she resorted to and found a higher power within herself. And that was compassion, and that was empathy. And she made a shift in her logical processes so that she stopped solving their problems and she decided to talk to them. And the result was a profound understanding in the human experience. That shift is something that I, as a scientist, found was somewhat lacking in the scientific community, and that has to do with the way we process our emotions. And in science, and historically the way science developed, emotions were supposed to be kept out of that process. If we involved our emotions, it would contaminate the scientific process. That's how I was taught. But it turns out that the emotions, as a neurophysiologist, was one of the things that we were never really studying. And I don't think we still understand the role of emotions. What I do know is that when emotions are taken away from a brain injury or a lesion, it's impossible to learn. So that there's some kind of process in which the learning process itself is interacting with an emotional process, which I think is what gives a kind of signature that allows something to become consolidated. It impacted us, just like when I was younger, the space shuttle catastrophe or Kennedy's assassination is an impacting moment that never leaves my consciousness. I think that when we're talking today about extinction and extinguishing, we should also pay attention to the fact that the wisdom in those days, in the 70s, was life is not a problem to be solved, but an experience to be lived. And I think at some level, we can solve ad infinitum, but we're going to have to learn how to emotionally deal with our inability to solve problems, and that's a different process.
Thanks. I agree with you. I think that's very interesting. I'd add maybe a couple comments. One is I don't think there is such a thing as emotional science, and you may agree with that. I mean, I was taught the same thing. I know many scientists who think they're working without emotion, but it's always there. You may try to suppress it, but any scientist will have their favorite theory, and you may try to be as unbiased as you can, but I don't believe that you can entirely decouple emotion just because we are human, and I think that's just the way it is. Well, I'll just leave it at that for now, if anyone else wants to comment.
I mean, a related question that's very challenging for those of us in the scientific community who are interested in these questions is the subject of activism. When you care passionately about a subject and yet you're trying to be a, quote, objective scientist, you know, number one, you have to be very careful to, you know, just the facts, ma'am, like call it the way you see it, no matter what the evidence is telling you. But number two, obviously we direct our science in certain directions because we really care about some of these societal questions. We're concerned, those of us who are scientists who are here are concerned about these questions we're talking about. But you know, how do we stay honest? How do we mesh our scientific supposed objectivity with our concern, our emotional spiritual concerns about the subject matter. And I don't think there's an easy answer to that. I think it's something that we in the scientific community, particularly in these fields, are actually wrestling with. Now, there's a woman in the center here who's been very patient. Yes. Oh, okay. Yeah, we're getting close to the need to take a break, so I think this will probably be the last question before the break, and then, yeah.
Hi, well, thank you very much. It's been a very interesting day, and I think what I say ties in with a little bit with the debate from before lunch as well, and also with the phrasing of the question. The way that it says long-term relationship with technology and the biosphere strikes me that it's something that's recurrent through some of the panel discussions is our relationship with technology rather than through technology, and perhaps the positioning of technology as something beyond us or out of our control, whether it's because it's providing game changers that we can't predict into the future, or whether it's because of economic lack of control. Somebody had mentioned earlier about lack of investment in certain technologies. So I was just wondering what the panel thought about our relationship with technology, whether technology is something beyond us, whether it's something that we control, which links in with the kind of emotional drive in science rather than the objective drive in science, and whether through reimagining our relationship with technology, kind of reclaiming our control over it, our ability to guide it, rather than letting it something that just happens. And I suppose because technology in the last 100 years has happened so rapidly, it can feel like it's very much out of our control. But whether the panel think it's possible to reclaim our control over technology and to guide it, or whether technology is something that inherently is self-guiding and self-propelling and evolves in a way which we cannot predict nor direct, and whether that changes it. Thanks.
Yeah, but just let me quickly say technology and commerce are kind of intertwined, meaning technology and capitalism. And in that sense, I think we'll always be in a push-me, pull-you relationship with it, sort of a multi-headed push-me, pull-you for that animal in whichever book that was. It's always...
Dr. Dolittle.
Yeah. In other words, the thing that will get us through in situations like that is our variegated nature as a species. There are capitalists, and there are libertarians, and there are liberals. There are tree huggers, and there are loners. And it's that nexus where they all meet where you're going to see this kind of dynamic, whether it's with GMOs. I think there's fundamental irrationality and some opposition to GMOs, but I think there's also rapacious capitalist interests in the ones we hear the most about. And it's the dynamic, it's the variegation in our society. So even though it's so ugly and polarized and weird, democracy is probably the solution to that problem overall. Our relationship with technology will always be like that to me.
I can't help but point out that your answer seems to contain the implicit assumption that capitalism is eternal and permanent, and that capitalism will always be with us. I'm not a raving anti-capitalist myself, but I mean it is interesting in these discussions. I mean, it's not the fifth law of thermodynamics that the world must be capitalist.
I haven't been
if we're thinking of
Beijing
the
yet,
long-term future.
Yeah,
anyways.
It's going to be around for a while.
Yeah.
But let me suggest to you that the problem isn't, in fact, the industrialists or anything like that, because it's the technology, and it's our relationship with the technology that you're trying to get at. And there are plenty of studies around. You go to any restaurant and look at families, and they're all looking at screens. Right? They're not talking to one another. Now, that might be a problem, right? But it isn't, and you can blame the guys who blame, Marty, whatever his name was, who developed the first cell phone. You can blame him for that, but that doesn't sound very profitable to me in any sense. I think here's a good example, the invention of the automobile. That changed everything for a lot of people, for all of society, right? And it wasn't driven from the top. It was what people found to do with it. It decentralized the cities, probably not a good thing, right? But it gave you freedom, probably a good thing, right? It gave teenagers a place, something to do, right? Right? So, and that's all driven from bottom up. So I think that any attempt you make to sort of direct our interaction with technology from the top down, it's going to be resisted. It's like people who put bumper stickers on the cars that say, baby on board. The difference between America and Europe can be read in the reaction to those kinds of bumper stickers. In Europe, it says baby on board. That's it. In America, people immediately push back, mother-in-law in trunk or whatever. So I think you can't get away with top-down directives here.
Yeah, I mean, just, I feel like I have control of this button technology here, and I can handle that. But that, when you get to this technology, you know, I have the NSA tracking my messages and where I am and all of this. And so these technologies that are system-wide that we're embedded in are shaping us, and we have only limited ability to shape what the NSA does with this information.
Yeah, I'll add to that. I think technology is part of our evolution. It has been for a very long time. And just very briefly, there's a quote from Desmond Morris, the zoologist, that I kind of like. If you take technology and civilization to be at least somewhat synonymous or hand in hand, he describes civilization as a backpack containing a first aid kit that's so heavy that when you wear it, it causes blisters on your feet that require first aid. And to some extent, I mean, we do obviously get benefits from technology, but to some extent, I think that is true. Yes, you get cars that create a lot of problems that we need more technology to solve the problems of. And so I think that it's an interrelationship, for better or for worse sometimes.
Okay, well, thanks very much. We're going to take about a 20-minute break here, and then we'll come back for one last session where we have all the panelists from the day who will come up, and it's a free-for-all between them and the audience. So any remaining questions that didn't get answered, bring them along, and there's refreshments in the back, and let's thank these panelists one more time.
How's that going to work, having 12 people up here?
This has been a presentation of the Library of Congress. Visit us at loc.gov.